Something fundamental changed in how software gets built, and most people missed it. For 3 years, AI coding tools meant one thing: autocomplete. You typed, and a model guessed your next line. GitHub Copilot popularized this in 2021. Cursor, Codium, and others followed. The interaction model was simple. Human leads, AI suggests. That era is ending. In June 2025, Anthropic released Claude Sonnet 4, positioned explicitly as an agent-first model. Not a better autocomplete engine, not a smarter chatbot. An autonomous coding agent designed to plan multi-step tasks, use tools, and execute across entire repositories without constant human prompting. Anthropic made it the default across free, pro, and enterprise tiers simultaneously. That's not an experiment, that's a declaration. So what does agentic coding actually mean in practice? It's worth being precise, because the term is already getting diluted by marketing. A Copilot-style tool operates in a single turn. You write code, it suggests a completion. You accept or reject. The human maintains full control of sequencing, file navigation, and architecture. An agentic system operates across multiple turns autonomously. You describe an outcome, refactor the authentication module to use OAuth 2.0 and update all affected tests, and the agent decomposes that into subtasks. It reads files, identifies dependencies, writes code across multiple locations, runs tests, interprets failures, and iterates. The human reviews the result, not every keystroke. The competitive landscape confirms the shift. In March 2024, Cognition Labs unveiled Devon, marketed as the first AI software engineer, an autonomous agent that could handle entire development tasks end-to-end. It was polarizing but directional. Cursor, which raised over $60 million in 2024, evolved from an AI-enhanced editor into what its team calls a code agent platform, integrating background agents that run tasks while developers focus elsewhere. By early 2025, OpenAI launched its own Codex agent, capable of spinning up sandboxed cloud environments to handle coding tasks autonomously, then surfacing results as pull requests. These aren't incremental improvements to autocomplete. They represent a different interaction paradigm entirely. To understand why this matters, watch what happens inside a typical agent session. A developer assigns a GitHub issue to an AI agent. The agent reads the issue, examines the repository structure, and forms a plan. It identifies that resolving the bug requires changes across 5 files. It writes the patches, runs the test suite, encounters 2 failures, reads the stack traces, adjusts its approach, reruns, tests pass. It opens a pull request with a description explaining what changed and why. The entire sequence might take minutes. The developer's role shifts from writing code to reviewing it. This is a qualitative change in workflow, not just speed. Claude Sonnet 4's positioning is instructive.
Anthropic described it as optimized for extended agentic tasks, designed to maintain coherence across long, multi-step operations where earlier models would lose context or hallucinate tool calls. On SWE Bench Verified, a benchmark that tests models against real-world GitHub issues, Sonnet 4 achieved leading results. More telling than raw scores is its architecture: improved tool use reliability, better instruction following across long sessions, and reduced tendency to take shortcuts when stuck, a common failure mode in agentic workflows, where models fabricate outputs rather than admit uncertainty. Making this the default model across all tiers signals Anthropic believes agentic capability is now table stakes, not a premium feature. This shift demands a new evaluation framework for anyone choosing AI development tools. Raw model benchmarks, pass rates on human eval, coding contest scores are increasingly insufficient. 3 dimensions matter now. First, session APIs. Can the tool maintain persistent context across long tasks? Can sessions be paused, resumed, or branched? How does it manage token limits over extended operations? Second, tool ecosystems. What can the agent actually do? Read and write files, execute terminal commands, interact with browsers, manage Git operations? The breadth and reliability of tool integrations determines what tasks the agent can realistically handle. Third, and underrated, scaffolding quality. How does the system recover from errors? How transparent is its planning? What human-in-the-loop controls exist? A brilliant model inside poor scaffolding produces unreliable results. The enthusiasm deserves tempering. Autonomous agents operating across codebases introduce categories of risk that autocomplete never did. An autocomplete suggestion that's wrong is ignored with a keystroke. An agent that autonomously modifies 15 files, introduces a subtle security vulnerability in one of them, and presents the result as a clean pull request, that's a different failure mode entirely. The review burden shifts, but it doesn't disappear. access control becomes critical. An agent with write permissions to production repositories carries real consequences. And compounding errors, where an agent's flawed assumption in step 2 poisons steps 3 through 10, remain a genuine challenge even in leading models. The trajectory is clear, even if the timeline isn't. Coding AI is moving from suggestion to execution, from single turn to multi-session, from tool to collaborator. The companies that win this transition won't necessarily have the highest benchmark scores. They'll have the most reliable agent infrastructure, the best tool integrations, the most transparent planning, the most graceful failure modes.
For developers, the relevant question is no longer which model writes the best function. It's which system can I trust to operate autonomously across my codebase and deliver reviewable results? That's a harder question, and the industry is only beginning to answer it honestly.